accessing the information.
Right.
So, yeah.
That's
So that's another challenge to working nationally to do this.
Yeah.
You might have seen some of those challenges since you were.
Oh, I'll be here.
Yeah,
I'll be back and
I think
forth,
I was
because
more
have to
on
get stuff set
the
up.
technical back
Okay.
data side,
Right.
and that's where even having different data formats causes to not talk to each other.
Hi.
Hey.
How long people are looking for?
Oh, God, this room looks familiar. Yeah, I know what this one is.
All right.
How you doing? Good.
So one of the.
I'm in for the front row.
That's good. It's an interactive, straight up session on information architecture.
Okay.
Dry download. What the heck is that on my card?
Yeah, but we go with open data and they.
I love it when the computer does interesting things to you.
APIs to input all
Are you
the
guys here?
or whether they're creating APIs that
Come here.
you know, to be able
Get rid of
to
this.
talk to the, but they are making some of these things like
Save.
their software is going to a web-free browser. Remote. Yeah.
Congratulations on your scholarship.
Thank you. It's actually not a scholarship, it's just an award. Not just an award, it's an award.
So
Well, that's still nice.
Yeah, it was really nice. I was surprised when I got it. When I first saw the email, I'm thinking, is this really meant for me? I want an award?
expectations are there.
Cool.
You deserve it.
What's that?
You deserve it.
Thank you.
Yeah.
Yeah,
Who's more deserving?
exactly. Ourselves, right?
Great. I got my first award from the state of Ohio this year, so I'm happy.
Congratulations.
2016 best practices.
So,
I feel like I've been doing.
I have an interest in your GIS stuff only a little bit because I did this medical hackathon.
Because like.
Okay. I'm
You
familiar with
heard
that
of
one.
So I was, the first year I did it, I think it was last year or the year before, and we won third place. And we used the idea of a GIS system in the health department.
Okay, that's excellent. That's where I started at.
Okay,
It looks like we're going to have a really intimate setting on this one,
yeah,
because I don't think most people understood
Yeah.
that this is information architecture.
I think your description was a little too short,
Yeah,
but hey, you learned, right?
they picked me up at the last minute. This is actually set up for the GIS conferences I attend.
Oh, okay.
So the other one has
I
like
think
a
it'd be
unicorn in its name, which I think is like,
Yeah,
that sounds really fun.
well,
You know, if you
I
want to throw in a
guarantee you're not going to
unicorn
fall
into
asleep
your,
in this one.
you
Okay.
throw in a unicorn into your presentation, I mean, it just pops.
I
Yeah.
put on interactive presentations.
Very cool.
My reputation at the GIS conferences is you go to Woody's,
Mhm.
you're going to learn, you're going to have fun, but you are going to be asked questions.
Are you like the Sam Woodard?
No, I'm John Woodard.
I know, well, there's a guy I work with, his name's Sam Woodard.
Yeah.
He's from like Wisconsin or something.
I'm not familiar with him.
No?
But since we have a smaller crowd in this one, it'll be nice and interactive for you.
Okay, cool.
Waiting for her to come back because she just stepped out. Those things are addictive and dead.
I'm probably gonna eat the whole thing. I'm
That's why
still
I've
hungry.
I've been visibly restraining myself.
The thought actually went through my head when I went to grab the second one of, how many calories is this? And how much weight on my belly is gonna happen? Oh, are we recording?
Yeah, I think
People are
we're still
probably thinking
broadcasting.
Oh, we were funny conversation.
Are you ready?
Me?
Yeah. We have a small crowd, so I'm gonna keep it even more interactive than I normally do.
Okay. Do the best I can.
I'm tempted to have you guys all sit in a group, but
Yeah, why not?
I
I will.
move the front row.
yeah, just move up to the.
I can
front
move to the back row. We will.
Okay, sounds good.
Well, it looks like we have a jacket from somebody else back there, so we might be doing,
Not the back row, but I can move to where you guys are at.
that's
Like,
fine.
that's one of us.
And make it easy for you guys to convince and ask questions, which is the purpose. Okay, we ready? I'm not sure what time I'm actually supposed to start, but I can talk, so it doesn't bother me.
Starts at 11:15, so you're
They're right on time.
on time.
All right. Welcome to the presentation called The Nuts and Bolts of GIS, Elevating the Lowly ARC Reader into an Information Sharing Dynamo. Now, I'm going to explain that title in another 2 slides. But first, it's only fair. Oh, by the way, I move around a lot, which is why I have a clicker. So, about me. I hold the GISP, a Geographic Information Systems Professional certification. I'm also certified as an enterprise architect. So this will be a lot of information architecture. For the last 10 years, I've been the GIS coordinator for a company called Chagrin Valley Engineering. And before that, for 6 years, I was the GIS specialist / coordinator for Summit County Public Health in the field of community health. And finally, I have 10 years with the United States Navy Seabees. Most of those were as an instructor. So I tend to project my voice. When you ask a question, I'm not barking at you. I'm projecting so people in the back of the room can hear me. I always tell that because I had one presentation where I had a girl who was terrified at the end of it because she asked 3 questions and she thought I was mad at her. So I do hold a master's in geography and GIS from the University of Akron. I have working on a master's in digital science / enterprise architecture from Kent State, and I will graduate in May 2017 because my thesis is still going through the process. And the thesis is information architecture in the field of GIS, in case you wanted to know. So on a personal note, I am a scuba diver, and I do keep bees. So every summer I deal with about 400,000 girlfriends and I sell their honey. All right, now moving on here. So this is where we diverge from information architecture in a way, because first I want to ask a question to everybody here. Does anybody know what a geographic information system is? 2 other. You don't?
I mean, I have an idea.
You have an idea. I want to hear your idea before I go with theirs.
Well, I mean, geography, does it have anything to do with geography?
It does have something to do with geography. Geography is a very important component.
See?
Okay, let's move on down.
I could be wrong. I just assumed it's like a map of
It is a map.
geographical information. That uses the geographic.
That's good. I like that.
Yeah.
You're right, and you're right. You're right with geo. You're right with cartography.
So you're mapping out where the information, the different services are. So I know Summit County Public Health is tracking data on, you could be tracking data on a health issue or
Right.
like the infant mortality issue. In Summit County and throughout the United States, you could be tracking where that has occurred. There's
Okay.
been infant mortalities and map that data out to give people a better idea of where those needs are to
Right.
be able to develop services for that need.
Very good. Each of you has a different component that makes up the definition. Your information, your mapping, your geo. What you're looking for, what I do, what GIS does, it takes your databases and places them on the Earth's surface for analysis so you can look for patterns. What you need is what we call, whoever wants to call it, a geospatial index, a geoidentifier. It's something, a piece of information that ties the map information back to the surface of the planet. That's normally an address. Some people use zip codes. I recommend against that. Census tracts for public health. Addresses, parcel ID numbers for county information. But that's the key thing. You have to have those connectors to go back to the planet to look at your patterns. That's why Infoline is part of the 211 system. But if they were in 911 and doing what we call a reverse 911 call, where the emergency center calls you on your cell phone, landline, they use addresses for that. They can't use phone numbers because phone numbers are made up. The 3 O's, the area codes, just like zip codes, they don't relate to the Earth in any actual connectivity way, physical way. The zip code is created by the post office. They change all the time. Your building address is also assigned by the post office, but it only changes when the building is removed from the parcel. Does that make sense? So you need something that's semi-permanent. So the other purpose of GIS is to share your information. And we share it through a variety of ways: maps, databases, Excel sheets, websites. It's limitless. So the primary purposes of a GIS system is: 1, visualize your data; 2, share it. And that brings us into a technical glitch. There we go. So this is an example of one of my maps. Obviously, it's called FEMA flood hazard areas in the village of Moreland Hills. So when you're working with maps, you always got to give them a title. Tell everybody what direction's up, north scale, and all that. But in the world of information, what do you think you need to know on this map?
Where flooding's occurred.
Where floodings occur. You're an information company. What do you need to make this map work for you?
What kind of company are you?
Huh?
211.
Oh, 211.
Social services.
Yeah.
Speak up so the mics can pick you up.
Oh, yeah, I forgot what kind of company we were, so the 211 Social Services, yeah.
Well, I know just as a private citizen that I looked up a similar map to make sure I wasn't buying a house
Right?
in a
flood zone.
floodplain.
Yeah.
So probably as a 211 provider, we want to make sure we get that information out to our clients so that they can make similar decisions.
That would be good. First thing I want to tell you all to look for is the source information,
Oh, to know how good the data is.
right?
Yeah.
It tells you the date of the data. That's important in information sciences because our information, especially in the world of GIS and mapping, it expires almost as fast as I can get the map out. And it tells you database. Some people actually put the data paths on these maps, but it's just like a term paper. You want that source information. If you see a map, newspapers are good for this. If you see a map graphic that does not have source data, do not trust it. But what else is on this map that you might find useful?
A legend?
The legend? Yes, that's another thing. Always have a legend on your maps. Make sure the maps that you're seeing have legends. But look what else is on here. There's little buildings. Now, this is a paper map. So this is what we call flat map or hard map. But in the world of GIS, behind this map is at least 2 databases. One of the databases comes from the county auditors, and it contains all the address and parcel information on that map that they have. Doesn't necessarily mean that it's in a current format or it's up to date. But what is generally up to date from the other database comes from the county engineers are the parcel lines. So this map will give you a general idea of location. But if you're sitting at your desk, working on your computer, it doesn't really help you. Does this map help you at all?
Well, if it's out of date, no, because live data, like you said.
Right? But think away from the paper. It's a paper map right now. It's a flat surface. Can you use it with your computer? Yes.
I mean, it's a reference, right? So
Yeah.
there would be some information comparable
Right?
to your current situation, your current need.
But what if you could take this map and look at the data behind it?
Hover over it and see what is
Right.
the percentage of floodage for this particular parcel.
What if I gave you a structure that actually allowed you to work with the data in the map and click on it and query it yourself? So we move beyond the realm of paper representation to one where it's going to be a data representation across the earth. Because that's really what we're looking at in this map is what are the pattern of the flood zones based on a reference to the earth, which in this case is parcel lines and buildings. So we are across that one. Let's back up here. So what I'm going to go with here is the software package that makes this map is called Esri ArcGIS Desktop. Are we all familiar with that? No? One, okay, you're not. It's a good software package, but the drawback is it's expensive. As students, and as professionals now, Esri's come out with a new program where for $100 a year, you can have a license at home. But you're not allowed to use that for commercial purposes. However, you could use it for doing maps, setting up maps, whatever, and learning the software. In the software package, there's a viewer called Arc Viewer. That will allow you to set the maps up to be exported to another computer so somebody else can look at your work and the data behind it. Okay? Now, this is where the information architecture comes in. Because if you're sloppy in your information setups, you're not going to get good maps. And more importantly, when you transfer the data, the map and this data to somebody else, they're not going to have any idea what's working with it. Now, in my world, I often have to set up maps for cities. I have 14 cities running off the Arc Reader platform. And out in those 14 cities, they have a copy of what we call the geodatabase. The geodatabase is a database that you're familiar with that contains all the geographic information for that city. So it contains parcels, streets, sewers, water lines, and things like that. So each city, 14 cities, have each a copy of this database. Now I've condensed it down to one database for each county. So I don't have to have 14 or 6 different county databases sitting on my computer every time. So one database for Cuyahoga County supports 14 cities. They each have a copy of the database tied to Arc Reader. Arc Reader allows them to view it, to call up information behind the map and see it. Like I could click on that parcel right there. I'd have the address, ownership, whether or not it's connected to sanitary lines, whether or not it's got a storm sewer, all that. I could even tell you when it was bought. But 90% of the time, I, as a GIS professional, don't need to know that. I'm passing this off to engineers who are now planning city infrastructure projects. Like, we need to buy an easement for the sewer. This property has this owner, the property value is this, so we can offer an easement value of this, and they can call up the arrow behind it and say, we can't put it here because this is the guy's favorite fruit tree. We have to move it over. The only way that program works is if I keep it organized. If I use data standards and data principles. So we've defined this. So we're going to move into this as we go into information architecture. What do people expect from their information or GIS systems? How about, it's got to be relevant. I can't give you a piece of information for, say San Francisco when you live in Cleveland. That does you no good. I have to be able to update it. So I update when the county updates and you get your updates. That works out about twice a year. Because the counties, even not all counties have the same amount of staff. Some counties can update almost live now. Some counties are still lagging behind. So you have to put that information somewhere in the map, like that source box we talked about. Most importantly, they want to make sure that their data is protected and secure. That doesn't mean they're not going to share it, but what they're looking at is no one's going to change it on them without their knowledge. Engineers, auditors really don't like it when they come back to something and see something's been changed on a map, but it hasn't had their approval. Because when you put together a parcel, you have to submit that parcel map to the county engineer for them to accept the survey work that was done. So, but in the world of GIS, you can change those lines through the software package and print out a map that looks official. Or change the line to make it look, well, my neighbor's fence is 10 feet on my property because this is where the parcel line is. So when you're looking at parcel lines and maps on the internet, you have to remember the data is only good as it's been surveyed and certified by the county. So we protect the data for the Arc Reader program. Now, what else do they want? They want everybody to be able to use it. It's an enterprise system at this point. What's an enterprise system? Can anybody give me a definition of enterprise in the world of information?
It's
Look at
used by
you.
multiple people.
Yeah, that's all it is. It's simple. It's a simple definition, but it's complicated to get to. Because what you're actually doing in enterprise architecture, if you go by the definition, is you take all the resources of an organization, align it to support one vision, one goal, the company's mission statement. That in a nutshell is what enterprise architecture is all about. They don't tell you, you have to get everybody on board with this. And you have to explain to the company heads why it's so expensive to draw up a diagram with their information flow, and then have a series of meetings as to why everybody wants their input in that same information flow. But the reason I'm bringing that up is because when you're establishing these systems, you're making mini enterprise architectures. You're making a modified, or what I call a mini enterprise system that you're now going to deploy to a foreign server. Because what you also have to address is accessibility. They want that information once it's installed on command, mouse click, whenever. They want it to be fast, and they want it to make it easy for them to understand, because you're dealing with, quite often, mayors, council people, city staff people who do not have 4 or 6 years worth of college training behind them to understand all these fancy terms and diagrams and the map that you're showing them. So we have to simplify the map interface, not the data sets. That's where a lot of people get tripped up. And finally, it's got to be reliable. I guarantee you from bitter experience that if you go out there and you have a button on that software package that doesn't work, the word's going to get out within the city, within the organization, and everybody's going to say, don't use it because this button doesn't work. So you got to test it before you get it out there. Now, we covered this. See, I don't really follow my own slides. Here it is, the definition for ARC Reader. I let everybody scan that for a second while I sip the coffee. I hate reading my slides. We got it all done? Okay, so like I said, ARC Reader is a nice little viewer. It comes in the Esri package. Most people don't use the ARC Reader because they have the full system. But again, if you're deploying, you want to make sure that that system's available. So when you work with the ARC Reader system, it's just like Google Earth. You can view, navigate, you can print. You can deploy the data remotely to other services, to anybody to work with it. The key thing is it allows you to communicate more efficiently the data that you want people to look at, because now you're giving them a live map. I can put in a web service through Bing, Google, if you get the API, or Esri, and they have, everybody's seen the Bing web server, right? Map server, you click on it, it's like Google. Everybody familiar with Google Earth and Google Maps? Okay, basically, ARC Reader allows you to take your data and put it on Google Maps, but instead of Google, you use Esri. Makes it really easy for city employees to figure out what they're looking at. And then they can call up their data by turning on buttons, and the sewer line will pop in over top the street. Okay? That's the key thing. Remember what I talked about before. What did we say before with the geo?
Geography.
Right. Oh,
What did I say?
Did I forget to warn people that if you look bored or you're like going glassy-eyed, I tend to hit you with a question. Oh, I must have forgotten that one. Sorry. Anyhow, remember we talked about geo. You brought up geo.
Yeah.
So if I have the Google Maps service, and I'm dropping a line over top of the Google Maps service, I hope I'm in the camera. And the city employee can see their sewer line in relation to the street and houses. What have we just done with the data for the sewer?
Made it
It's a
accessible.
$50 question.
Accessible,
Yeah,
increased visibility.
increase the visibility. But what did we just do with that data? We gave it a geographic reference. Now the city can look at that sewer line, map out, hey, house 454 has a break in sanitary sewer. They're on a slope. That could spill down into the street below it. That is what they use it for. Now, the reason it's information architecture about this, we're going to skip that slide. I'm going to slip that slide. And we'll skip that slide. We'll come back to it. Information architecture comes into play because what you're now seeing is my desktop. See all that over there? That is the data layers to make this map. How many people, if I gave you that, would be able to work with that right away with no training? Okay? Maybe. Now, imagine if I put Google Maps behind it and put it in the viewer and say, go to it. You know what happens? Everybody can start working with it without training. Everybody goes through here and starts turning off layers, turn them on off, because now all of a sudden it's something that's familiar to them. Oh, wait, I can see Google Maps behind it. All right? So the key part of all this, coming back to the information architecture, is geodatabases. And what is a geodatabase? We'll go to you.
So geodatabase, well, for example, 211, we have our database and they use Google Maps to map
Right.
out all the different social service agencies in Summit County. Through our website, we have that mapping capability. So
Okay,
you can see this agency's over here, this agency's over there.
all right,
All of them, they do it by social service term. So you can see where all the food pantries are, for example, in Summit County. Their
Okay.
location, you can see gaps and whether there's one in this area or for this zip code, this neighborhood, or
okay, that's
all relevant information.
a really good answer. I wanted something a little bit more simpler, but that's good, because I need that information. Let's go back. What do you think a geodatabase is compared to a regular database?
I couldn't tell you. I'm not sure.
Okay, well, I'm glad you said that, because I needed that answer. Actually, I was hoping to get that the first time.
Sorry.
There's no difference to a database in terms of what they do, okay? Your IBM databases, I use those all the time. Microsoft Access databases, I use those a lot. The geodatabase was created by Esri. A geodatabase takes all the information that we just talked about from the other databases and puts it into a new database that basically makes it easier to tie it to your maps. The only reason they call it a geodatabase is because they say that it contains only geographic information. Okay? Geodatabases are very flexible. You can add Excel tables to them. You can add text files to them. How do I use them? Just like this. Now, going back to information architecture, remember, the whole purpose of this system is to make it remotely, I love it when I can't talk, to make it deployable on another servers remotely. Thank you. So what we do is, I build the schematic for the geodatabase here, okay? So we have general information, that's your buildings, that can be your information of note, buildings, zoning codes, just census tracts, just basic information. Land is another category. That's where I put the parcel information. Anything that relates back to parcel, you can put zoning there. That's where it becomes subjective. Going back to our information architecture, what do we do to prevent subjectivity from contaminating the system too much? We create formats, principles, standards. Each one of these databases contains its own information architecture, which I've made to keep up my office. But each one of these categories follows that architecture. So, for example, if I say parcel number, in my geodatabase, it's PPN. Every geodatabase I have is PPN. If I say sewer, and I have someone, an intern, mapping out the sewers, there's a drop down in that sewer table that tells you sanitary, storm, or combined, but that's it. They can't go any farther. Those are the three choices they have. Standardizing the data sets keeps it organized and keeps subjectivity from creeping in there. A great example of this is when you go to a county that has 4 different departments entering into the same data set. After you've worked with their data, you can tell when one person stops and one person takes over. Why? Because the abbreviations change. Some people, and this you can really see this in street data, some people will take and spell out the word road. Other people use a capital RD. Some people use a lowercase rd. And one person, for some reason, uses a capital R and lowercase d. What happens if you have a transposition? Road suddenly becomes drive. Your D goes in front of your R. That's a data error. That's incorrect. And going back to what I said before, the button, remember, if you have a piece of software out there and the button doesn't work and you deploy it to a city, I guarantee you, the entire city will consider that software package a failure because that button doesn't work. Now, this is one of the things we hadn't talked about before, is when I'm visualizing data, remember, that's my job as a GIS person. I make visual representation of data sets. If someone's living on a road and I call it a drive, are they happy with me? Is that map, is that information accurate as far as they're concerned? Is it? I see a lot of people shaking their heads no. So no, it is not accurate. And what happens when you give someone a piece of information that is not accurate or true? Will they trust your data set? And that's another reason why I do this, because I have to ground proof all this, ground truth it is what we call it in mapping, and make sure it's right before I put it out there. Now, my data sets, my geodatabases, they used to be small. But when you're working on counties and you're working on cities and you keep local information in there, one of these geodatabases right now, I think my smaller one is running 10 gigabytes. For cities like Avon and Strongsville, where we've developed them all the way out, you're looking at about 30 gigabytes of space. If I throw in the databases for the plan sets, you're now looking at half a terabyte of space. And if I throw in aerial photographs for custom projects for the city, you're now looking at 1 terabyte maxed out. They're not all that, but that's the potential you could be dealing with one city. Can one person go through all that and catch every piece of information? No. That's why we go back to information architecture. That's why you have to build in those data principles, those standards to protect yourself. Again, by eliminating transpositions, misspellings, people's own way of abbreviating things, and more importantly, by having the city check the street list and things like that, when you set up your database, we call those domains in the world of GIS. In Access and Unix and SQL, they're called lookup tables, if I recall correctly. You've eliminated 95% of your potential data errors. Is that a good ratio? Is that a good percentage? To say that your database of 5 gigabytes has plus or minus 5% error rate? How many people think that's good? You guys are starting to catch on to me. It is good. That's what I call the rough final. But then you have to go back through. I don't like to release a data set unless I'm at the plus or minus 1% or less in error rates. You're looking at me like I'm crazy. Am I crazy?
No, I guess the question is compared to what, right? I mean,
Mhm.
you're taking this information, like say the city of Strongsville, I mean, how long have they had a map, a digital map?
Let's see, we built it for them 2.5 years ago.
Okay. But before that, I mean, if you were searching like Google Maps or, I guess, I mean, from my point of view, I'm thinking about this in terms of like how long has this information been online? If you're trying to standardize it, what are you comparing it against? And like, how far are you gonna go back to try to track a data error?
That is a very good question. And I only go back to when I create the data sets because I'm working from county information when we start this. So the county information tables are filled with, and I'm not trying to bust any counties here because counties don't have a lot of manpower and they don't have a lot of funding for this project. But you have to go through and you have to go through the county tables when you trim the data down in relation to the city. I look at that and I come up with my percentages by saying this table has 5,000 entries in my sampling of I usually do 250, 500 entries. I found this many data errors. And so I create the percentage. And then we go through and we clean out the table. And one of the ways I clean out the data table is I send back the street listing back to the city and say, I need the city engineer, the service department, and most importantly, the secretaries to go through, or administrative assistants, to go through and make sure all these street names are correct. You'd be amazed at how many street names the city has that the county doesn't have. Because no one passed the information over to the county.
It's all done in paper.
It's all done on paper.
Yeah.
So that's how you lower the data rate. So I look at the overall data set when I first get it, figure out how much error it might have, and I trim it down. So when I'm done, I can look at it and say, this data table of 1,000 names, I have less than 1% error on the names because I've sent it back to the county. I had them check it. I had the city check it. I had my people check it. So all the misspellings are out. All the transposition of letters should be taken out. And that'd be a spelling. The formatting has been standardized. So we no longer have a road that's called Avenue by the residents that's listed as a road by the city that's listed as a drive by the county. All that's been eliminated. You see, when I say that, the 1% relates to the geodatabase, not to the county data set. It relates back to the city.
So whose opinion counts the most there between the city and the county and the resident?
As to what it is?
As to what it's called.
Oh, wow. I've dealt with that numerous times. I will say that if you're working for the city or the county, the person who has the utmost to get things done will be the resident. Because the residents are the ones most impacted by the data. For example, I had to change a Google map address. In Moreland Hills, there's a street called Lancaster Court. In the old mapping systems, the street was called Lancaster Land Road. It was a private development that was then turned over to the county. The street name was changed, but that information wasn't given. When Google went through their street data and pulled it down from the county, they didn't get that change because in the data set they got from the county, the change had not been made. It was sitting on someone's desk. What happened was the resident went to register to vote this past election, and she was told by the Board of Elections that she could not vote because she did not live in the county. Because the Board of Election uses Google to check the street addresses that people put on their cards. Their search of the index did not return Lancaster Court. Why? Because that column of information, that data table, didn't have a Lancaster Court. It had the old street name, which was Langley? Yeah, Langley. Okay? I called the county. We changed data sets. The county got theirs fixed up. I called Google and I had to talk my way through. Now, Google has an interesting process of fixing this. And they were very responsive, but you have to go to the lower right corner, click on a map, and find a little tab for problems. Enter the information to Google, kicked it in. I met one of their managers at a conference. I called him up, said the information's on the way. He's actually one who taught me how to do this because I couldn't, for life of me, figure out how to make it work on the website. A week later, the new street name showed up on Google. So the resident was able to vote. And that's what drives all of this. So when you ask what's most important between the residents, the city, and the county, it's always going to be the resident. Now, that doesn't necessarily mean that the resident is always right. But things will happen faster if a resident calls and says, I need to understand why this isn't happening. When you get to the city level and the county level, that's where you have to sit down and discuss it with the different departments because you have all the politics and the legal stuff. But in the world of information, especially in mapping, you want to assume that your local information is the most accurate that gets passed up to the county. And then the county information is built for the local information, and then that moves up to the state. And then that will move up to the national level. In reality, it doesn't happen. It's starting to, but the United States as a whole has not developed that big information network nationwide. We're working on it in bits and pieces. But you have to remember when GIS came along and information sciences came along, in the world of state, local, national governments, everything was being done by hand, by paper. You had guys in the county office, they had whole rooms with big desks with people drawing hand maps. That's the way it was done. So you're working off of that architecture now. As more and more people come back into the counties who are used to newer technology, it's starting to spread. But it's hit or miss as to whether or not the information actually gets moved up as fast as you'd like it to. The county the county is the governing authority. The cities are underneath that. In the hierarchy, in a straight hierarchy, the county will be most important, followed by the city, followed by the resident. But it's messier than that because the county and the city's authorities overlap. And in some areas, like roadways, the county is required to maintain all the roadways that are county roadways through a city. But in winter, the city will still plow that roadway because they need to keep it clear for the residents. Does that make sense? I'm giving you a real answer instead of simply saying, hey, the county's the most important with the city, because it doesn't work that way. They work together to get things done. And 99% of the time, it's a great teamwork. Yes?
I'm just curious how you determine data error percentages. Do you look at the field or do you look per instance of data error?
I look through all the fields, and like I said, it's a rough and ready thing. I look at all the fields, figure out for my sample how many errors I have per sample, and then I just move that up to cover the entire table.
So if you had 2 errors per field, you would count both of them?
Yes.
I just audit data errors, so I was curious how you did it.
Good, because I'd like to find a better way of doing it. But yeah, some of my tables, when you look at them, when you look at Excel sheet, they'll be 100 and some fields long. I can't say that, if I just look at one field, I have one data error there and say, okay, if I eliminate this, now my table is good, because that one data error can carry all the way across the other 50 columns. But we're not going to talk about that today. We're talking about how to get this thing live. So the main geodatabase is copied to the city. That's called the information geodatabase. And this is the one that will be deployed out there on the city servers. And we have the tech glitch again. I love technology. Oh, the computer is telling me that's out of power. One moment. So when I transfer the data set over, the key thing you have to remember is all the map layers that I showed you right here are connected back to that one geodatabase. The ARC reader system is a copy of this. That is important to remember, especially with information architecture. What's the thing we do in enterprise architecture? We map out information. We map out where it's going. We map out what the connections are. We visualize it in a chart format. I use a flow format. And it's similar if you, that's why the keynote speaker visualization is right on target, because that's what I do too. When you make that, you visualize it. So it becomes critical because there's an interesting thing about the ARC reader system. It copies my pathways. Okay, in the world of ARC desktop, each one of these is a representation of the data set. It's a dynamic link back to where that data is stored at. So when I copy that, how many people here have worked with pathways and information? Or URLs is another way of calling them. Hyperlinks is another name. If I have a URL that starts off at C drive to GIS forward, so it goes C, GIS, map, and that's an ARC desktop. When I move ARC reader over, it has to have the same path for all the data sets. Because what happens is city's IT department will put this on a server and say, okay, this is C drive, we're good to go. Then they install the program on everybody's desktop, it doesn't work. Because the data paths are actually related to what I call G drive, my GIS server. So when I go to deploy this, in order for this to work, I sit down with the department, the IT department, and I pull out my, what I call the information maps, and I say, in fact, I think I have an example of those coming up right there. And I say, look, this is how this has to flow. The information geodatabase needs to be housed on the G drive. We need to make a server called G. That one 10-minute meeting will save you about 3 hours of hassle of trying to figure out why this isn't working. I know because I've been down that road. So the geodatabase is now housed on G drive. Everything works because remember, I'm making a mini architecture. So this entire architecture up to the users gets transferred over to their G drive. It's a nice secured system for the users. It takes away the fear of if I hit a delete button by mistake, I lose everything. I can't because it's a read-only, except for a few extra keys that are added to it. There's an ID button that you can click on something, pull up the attribute table and read it. There's what we call a markup tool that allows you to draw circles and make notations. That gets saved off in its own layer. It doesn't affect the data behind it. So these mini architectures, I've deployed 14 of them in Cuyahoga County. I've deployed 3 in Lorain County. And I'm working on one for Summit County because we just took over Macedonia. These work. It keeps it all nice and condensed. But this is the enterprise architecture system, or the information architecture that drives the ARC reader maps. So when you go out and you work with people, we're not used to dealing with terms like information architecture, enterprise architecture. I literally had one guy ask me, is this Star Trek? I'm like, no. Are we building a house? No, we're making a plan for your information flow with the ARC reader system. Those are questions I actually have to deal with when I go out to the cities. And I say, hey, I got my enterprise architecture certification, I'm good to go. You just go out there like all of us, when you first graduate, you just have all this jargon up here. And it doesn't, the people you're dealing with don't have that jargon. But they love it when you put it in the map form. Am I going backwards? Yes, I'm going backwards. So that basically, in a nutshell, what I do with ArcReader, and like I said, it's information architecture. This is the underlying schematic for everything we just walked through today. And I bring it to your attention, and I brought it here when I was asked to present here because I want people to see exactly how you apply information architecture. I do this almost every day of the week now. And it really helps to be able to visualize it. I mean, this morning's presentation was perfect because I struggle with that. How do you visualize 1 terabyte of data to somebody who's never dealt with information or database theory? Underlying the ArcReader map system, I found to be the best way of doing it. Any questions? Because we're actually close to being done. Thank you for being a great audience. I hope everybody's still awake. Yeah, you are, because I asked you a question. So any questions, comments? Yes. Uh-oh, now I'm under the gun. They brought out the big guns for me. Can I hide?
With the, you use the IFS.
What?
One of the things
Stop me when I get there.
the PDF tables, which tables are machine readable.
Right. Those are, when I'm referring to tables, those are Excel files or SQL or Access databases that I'm accessing in that folder. Because like the parcel information from the county, when you download it, you get a flat file of the information that then has to be translated into Excel or brought into the geodatabase as a table or one of the shape files. These tables also will be an Excel file that shows like pavement condition. And this is getting a little technical, but in the information geodatabase is a street file. And what we do is the cities, when they're mapping out pavement condition, use street name, segment, condition, and in the table or the shape file for street, I have the same identical columns. So when they give me an Excel sheet, I bring that into the table library and use join on street name and segment to bring that information into the geodatabase, because then the city can alter that at their desktop and then show the new information on their own map without actually damaging any data sets. That's how that works. But yes, I'm not sure exactly what you mean by machine readable, but that's how we use it.
It's made into CSV files.
Okay. Yeah, that's done. The machine readable files are brought in prior to making the map in the architecture, because I have to convert that into an Excel file that they can use on their end to feed data back into the database. Because the Esri system doesn't work well with CSV in its raw format. You have to translate it into a database table. I wish they would do it in CSV format, but they don't. Anything else? Yes.
With some of the different, I would say, state and county trucks and everything having the components inside of them now.
Right.
Where they're getting to the point where they can actually see the roads or, kind of see the roads.
Right.
It's all digital. Can that data be sent back to a system like this so
Yes.
that they can actually keep up with it live? They can.
Right, but it's not piped to the ArcReader system. That would come up through the website, and that would go through ArcGIS Online. So it can be done. It is being done in some regions, but it's a different set of technology that allows it to do it. And it's also, when you're working at that level, the cost level is tremendous. Most cities can't support it.
Oh, okay.
This project here was done so that a city could invest, say, $5,000 or $10,000, but they get $50,000 worth of value, because now instead of repeating this system for every department, all they have to do is deploy the ArcReader program to a computer, and that goes back to the server, and then that department can look at their data in relation to everybody else's data off of one map. So I can support, right now I'm supporting 35 users at my office on our maps, and most of them have 2 or 3 maps open at one time using the ArcReader system. The city of Avon, currently I have 4 departments, and the entire council is working with the same ArcReader system. They all think they have their own map, but the truth is they just have a copy of the viewer. It's the same map system. It's more bang for the buck with this mini architecture.
Like, now, because a lot of times the different counties and everything, they actually will outsource some of the
Right.
different projects to vendors. And those vendors might not have the same capabilities within their trucks that the counties actually, their trucks may have. But they still have digital components within their trucks to be able to receive some of the information. Is there
Right.
some way to link back to their digital information to access the components? I mean, they're still working from paper maps, but they also have the digital information that they have to have from all of the, third-party
Right.
contractors that they're still utilizing. Are you still accessing that information or no?
I am not, but yes, there's the Esri system through ArcGIS Online allows you to tie in third-party vendors. The county IT department and GIS departments would have to give the third-party vendor the key, the security key to upload the data. But yes, it can be done. Again, it's a very flexible system when you're working with the ArcGIS Online program. It requires some special licensing, especially with a product called ArcServer that allows you to build custom forms through iForm Builder. And then you can run it all the way through. And all you have to do is hand them a tablet with an application, say, record your information or record information off the tablet. Or if you're doing an automatic update and live feed, you have to give them a security code and allow them access to where you can upload the data set into a geodatabase off the GPS units. But yes, it is very good. Yes.
So with them, each department having their own mapping, do you also offer layered maps of where all of the information is available on one map? Is there any helpfulness to that, or?
Man, it's throwing me off because the screen I look down at is backwards. There. These data layers, I can put them in customized groupings, but that's what they see. They don't have to dig through the database looking for a new map.
Right.
What will happen is like Lyndhurst, I actually have a layer in there called Building Department. And they just turn everything else off and they just call it Building Department.
Right.
Or if they really want, I go back to my desktop, I can make them a new viewer that has everything else turned off except the information that's pertinent to them. Kick that out. And I don't even have to go out to the city. I just email that to whoever wants it and they can install, download it, put it on their desktop, click on it, and it'll go automatically back to the proper route because I didn't change any pathways.
So you are able to show multiple layers
Right.
of data at one time if it's helpful to them.
Yes.
Customize it any way they want.
Right, but the key thing is, back to the information architectures, I'm not changing a pathway. I'm not taking out that G and replacing it with something else. When I do that, I have to rebuild the whole system, and that's when they get their bi-yearly updates from me.
Right.
Like with Avon, Avon was a big project. I was updating them once a month. They gave me access through the FTP. Actually, they gave me direct access to the database. I just transferred things over at night because they were IT departments really surprised at how much bandwidth a geodatabase filled with aerial photographs will suck up. It slows them down. But yes, it's customized mapping. The departments think that they have their own map, but it's running off the same data set. Keeps everything in relation. If you're not familiar with GIS, I would recommend taking at least the GIS 1 class either through online. Cleveland State has a 2-day class because it is a way to map your information and make it visual against the surface of the earth. And you don't have to have a degree in it to make use of it. But it is a good system, and there's a lot of open source software out there too. But I highly recommend at least having a basic understanding of it, because your cities, your clients are all talking GIS, and then a lot of grant proposals, RFPs have GIS components to them. Yes, I suppose it's lunchtime.
Just drop it in, we're running a little bit behind, so.
So we're just answering questions.
Oh, okay.
Any other questions? No? Was it understandable? Okay, everybody's awake, that's a good thing. All right, let's clear it out for lunch then.
Thanks.
Thank you. Thank you for being a great audience.
I didn't mean for you to have to wrap it up, I was
Oh, no.
dropping in.
I think they ran out of questions. I'm always available for more questions. I'm a chatterbox. I've been.
Thank you very much.
Thank you.
I heard about GIS work about 4 years ago at our AIRS conference. They were doing it in Texas through this STAR program,
Okay.
where because they were on a state system with their 211, they had access to all the data sets to be
Right.
able to map all the surfaces out. And it was fascinating. They had layers to it. So you could filter for whatever information you wanted about services. If you just wanted to look at one particular service, you could do that. Or if you wanted to map, 3 or 4 different services, you could do that.
That's
It was
beautiful.
fascinating.
Oh yeah, it's great when it works right. It's a beautiful thing. Thank you for coming.
Hey, sorry, I was talking to Marcia.
No, that's okay.
So I'm actually talking with Edwin about the possibility of doing something with our data, with GIS kind of mapping and that sort of thing.
I don't
So
have your business card with me because that's kind of like last minute. But let me have one of yours. I'll get in touch. I wouldn't mind helping you out with that.
we're also talking with Summit County Public Health, because they have the availability to do that sort of thing. So
I'm not sure who's over there doing GIS and some.
I don't know because my VP is working on that project, but I know that we're looking at that discussion about providing some of the data so they could do some more mapping with what we do. But I'd love to be able to have it available on our site, our website. That's why I'm talking with Edwin about it simultaneously. See how we end up doing that. But it's fascinating. I think it's so helpful for grant writers and nonprofits to be able to plan, what to do, and definitely our city planning.
And I'm familiar with your WebBot problem too.
I'm sorry?
I'm familiar with your little WebBot problem too.
Yes. So you have that issue as well then?
No, because I don't have a lot of stuff online, but I
Okay.
know people who've been hacked.
Yeah. So I have to check my, I have to do web reports every month to look at IP addresses and
I've actually used
All the things.
WebBots to find RFPs. and
Okay.
Potential grant opportunities.
really?
Mm-hmm.
That's interesting.
But when I do that, the package I use is called WebCrawler,
Okay.
and it allows you to set the levels that it will go down and search through.
Okay.
And what I do is I never allow it to go past the second level.
Interesting.
'Cause I don't want people. I don't want to be hacking people's stuff. Oh, I got a book. I'm good.
Interesting. All right.
Yeah, but
Yeah, we just had a discussion, about an hour-long discussion with our software provider about how to
yeah,
better deal with the WebBot and crawler issue, because it happens all the time that I do searches to make sure that our website is coming up as a top result,
right.
and see other predatory kind of websites that have all the commercials and everything, and I look at their data and I'm like, yeah, that's my wording right there. Hey.
I was
You
just,
ready?
yeah, I'm ready. I just was gonna offer to you lunch later to walking out, so. I did. I think maybe I grabbed this thing. I don't know if I-
Yeah. I know.
And community. All right, the next one is for a full license of Sketch. And that is for tap. I know you did. I know he was here. He couldn't be here, but I know he was here. So that's what I'm gonna do right now. Is for a full license of Justin Mines. that is Shanisha Collins. Who I also know was here at some point, right? All right. So what I'm gonna do now is play you the welcome video that we're gonna play this morning. I'm not sure that it's gonna play on that screen back there. It's only about 3 minutes, so if you wanna come over here to watch it, you're welcome to. What moment should you're not able to hear it back in the video again? So what we're going to do is put the welcome video on the YouTube channel, and you can all watch it on the YouTube channel where we have live streaming. You should have all gotten a link for that in your email when I sent out the virtual swipe bags. So we will put the video up there. Apologize for some reason we're not getting found on my computer. So, and no, it's not muted. So. Enjoy your lunch. We're gonna, we were a little bit delayed, so we're gonna start back at 1 with all of the presentation.
Okay.